Give you all a chance to catch your wits, because we're about to change directions a little bit here. We've talked about sperm cutting and epithelial cell cutting, and this is all great, and I think it's probably one of the most applicable uses of the laser microdissection. But it's not the only one, because remember the first day we talked about opening up your mind. What are other things that can happen? What are other things it can do? And we've actually looked at some of the other applications that can be used, other forensic applications of the laser microdissection. And that's what I'm going to talk about here. Actually, I have one talk here, but I'm going to split it in two, because the first part we need to talk about sperm identification, and then the other part is going to talk about diploid cell identification. But it's all part of the same talk here, but I'm going to split this right in the middle of it. We'll stop, and then I think we go to the lab and we do some microscopy at 11 o'clock.
So you have to double check. Yeah, I think. Is that right? Yeah.
Okay. But I wanted to talk about this before we get in there, because it's going to be directly applicable to that. Laser microdissection strengths, we've talked about that. I mean, Christine's talked about it, and I've talked about it, and we mentioned it all yesterday. Microscopic identification of cell increases sensitivity and minimizes handling. In reality, the microscope is an extremely sensitive instrument, because you can go in there and you can find one sperm in thousands and hundreds of thousands and millions of cells. Same in drug identification. We can find one crystal of a drug, one crystal of cocaine, and only be less than 1 or 1/10 of 1%. So with that microscope, you have exquisite sensitivity to find individual items. A lot of people don't realize that, or they probably, once it's said to them, hey, this is really great, because you can go in there and you can find 5 cells in a field of hundreds or thousands or even millions of epithelial cells. You can find a few sperm cells, or you can find any other type of cells if you can differentiate them in some easily detectable manner, or at least some detectable manner, some way to separate them. We see it's easily separate sperm and epithelial DNA. Christine's talked about that all morning, how you can separate, and you're really getting good, clean separations. And you all saw yesterday when you were cutting, here's some sperm, here's some epithelial. We can separate those. So you've got a really good strength in there, because you can get good, clean physical separation as opposed to chemical separation. Quantification is done by cell counting. I still believe that is a method of assessing human DNA. Next question says, okay, how do you know that's human sperm? Well, sometimes you don't, although they have a very characteristic ID, especially if they have the tail. But most of the spermatozoa don't have the tail. So there can always be the question, are these human sperm or non-human sperm? It's just one thing to think about. Where I'm going to go now is the fluorescent attachment. The fluorescent attachment provides new capabilities. It enhances some capabilities and provides new capabilities that even just the bright field alone cannot provide. So you can get, not only can get better techniques for sperm identification, but now we can get new capabilities of identifying other types of cells that we may want to separate. The fluorescent capabilities add the capabilities for analysis of all types of sexual assault evidence. You say, okay, well, what other types are there? Well, there's fingernail scrapings, bite mark, breast swabs, just skin swabs. So we can, not only can you analyze just sperm-containing samples, but now you have the capabilities of all types of evidence. Anytime you would have a mixture of male and female cells with the fluorescent capabilities, we could add that capability. Oh, that's a new one. Provides improved capabilities in sperm identification, enables new capabilities of identifying male and female diploid cell mixtures. Can y'all do that now? No. If you have fingernail scrapings, what do you have? You basically have to take your chance and mix and do a straight extraction. Or if you have a bite mark swab, you can't go in there and tease out the male cells. You can look at the mixture profile and say, okay, well, these match the suspect or the male in the if you have too many female cells in that mixture, as Christine was showing in preferential lysis, about a 1 to 20 mixture is about it. Once you start going below a 1 to 20 mixture of male to female cells or 2 different donors, you really start losing one of them. 1 to 20 means about 95% of the DNA profile comes from one person. 5% is what's left over. These processes are in the development stage. They're still fairly new. There's not a whole lot of products out there that can help you with it, but they have been successfully performed in an actual case material. And I'll talk about that, finish up with that later this afternoon and at the end of the day. What are some of the sperm identification problems that you have in your laboratory now? Well, you have few spermatozoa. Anyone ever sit bent over that microscope for 35, 45 minutes or an hour or longer trying to find 1 or 2 spermatozoa? After about an hour, just about anything might start looking like a spermatozoa. Anything that's got a little ovoid shape to it, you start seeing spermatozoa. That's why in our laboratory, if we spend that amount of time looking for a spermatozoa and someone does finally find one, they have someone else to come over with a fresh set of eyes because theirs has now determined that, okay, I'm going to find a spermatozoa. But we actually do, that's part of our process, is when you find 1 or 2, you ask another analyst to confirm it because you start looking for them. That's what you're looking for. You might have a bias towards saying, yeah, this looks like a sperm to me. So we want a fresh set of eyes in there. That goes back to another thing. 1, searches are often labor intensive. The analyst is uncertain about the ID. That's what I just talked about. You look at it a long time, you might say this little contorted ovoid shape there might be a sperm. Maybe it doesn't have quite the right staining pattern. But you're saying, yeah, you know, it might be. Might not be. And often, a lot of laboratories base their case processing upon sperm ID. There's a lot of laboratories that screen cases. They look at that slide, they don't see any spermatozoa, they're AP, PSA's negative, they go on. That's it. They stop. I'm sorry, they don't go on, they stop. That's the end of the processing of that case. But is that a true end, or is that a true process? And as Christine was talking about, they're spotting 3% of their product, or 3 microliters out of maybe 100, or 2.5 out of 50, or something like that. Maybe they're spotting 10% of the product, maybe they're spotting less. So they fail to search another 90% of it, and if they have few spermatozoa, they may have difficulty seeing it. You may also have an excessive quantity of epithelial cells. You may have a lawn of the female stratified squamous epithelium. Those cells in the vaginal wall come loose very easily. They're used, and that's part of the process. They're the same type of stratified squamous that you see in your mouth. They are used, they come apart, and they're part of the process is that they're shear forces that tear them, or not rip them off, or remove them. So there can be a large quantity of female epithelial cells in a small quantity of spermatozoa, because we don't get the samples immediately after the sexual assault occurs. Sometimes we may get it hours after the sexual assault occurs. So the number of spermatozoa has been reduced significantly. So spermatozoa buried under the cells, or hidden or stuck up next to a cell, so they're not very apparent. Then you have the same situation combined with few spermatozoa. You have a few spermatozoa and a large number of female epithelial cells. It makes it very difficult to see. You can search that slide and just overlook them. You may also have a poor or low quality microscope. I was at a college the other day looking through their microscope. I said, oh my God. I was trying to look at something, and I really couldn't see a lot of detail in a student level microscope. The light source was kind of yucky. The objectives had been through hell in the student microscope. They've had a lot of, it just does not the quality I was used to looking at. And then, as they talked about earlier today, poor staining. If your staining doesn't come out as well, they would, again, they say, hey, this Christmas tree stain works really good here, but sometimes it doesn't always work that well. So you put all of these together, you have a situation where you may have some sperm identification problems. One of the new techniques that we're looking at, and is coming out, is sperm labeling by fluorescent dye. These sperm ID or fluorescent sperm ID products are based upon antibodies conjugated to some type of Alexafluor, or Alexa-488, I think is fluorochrome. It's a fluorescent molecule. It's conjugated to the antibody molecule, And these antibodies are specific to human sperm components. Now, there's a couple of products out there. Sperm paint is one, sperm highlighter is another. None of them are currently on the market. We have had the opportunity to look at some of them. They do give a nice stain to the sperm. The sperm paint has 3 antibodies, one to the acrosomal cap, the equatorial plate, and I think the tail of spermatozoa. The sperm highlighter has a single antibody to the sperm head. They're very easy procedures. Sometimes it only takes about 5 to 10 minutes. One of the procedures takes 2 hours, but it's very little hand time. One takes maybe 5 to 10 minutes, but takes overnight. Easier, faster, and confident searches. I've looked at some of these, and I tell you what, it makes a big difference when you're looking at spermatozoa. You can screen through them very, very fast. And what's even more important, how many times have you looked at a slide for a long time and you're just not sure there's nothing there? You look at it, you don't see anything, and you walk away from it, and you never saw any spermatozoa, but you decide to go ahead with the process, you run the process, and now all of a sudden you get a nice profile in your sperm fraction. Anyone ever had that happen? Or do y'all stop after not finding sperm? So now, with this fluorescent labeling, I believe you have more confident negatives and more likely to find some that have positive samples on there. Backwards compatible, but not with the LMD, for laser microdissection. This is techniques that you can use on regular glass slides, although you cannot dissect the sperm off there. If you have this fluorescent attachment, you can still look at the older slides and stain them with a fluorescent technique. You simply cannot take them off, at least by the Leica or some of the microscopes. So there's a lot of companies now are selling these, or it's not selling them, but they're intending to sell these fluorescent ID products, which means you've got to get a fluorescent microscope anyway if you want to use them. Which, Andy, what's the price of the basic fluorescent microscope?
Basic fluorescent microscope start, good one for your quality, should be at least in the mid-teens to $20,000.
Okay.
Without any imaging device.
Just look at the microscope.
Microscope only. So expect on spending $20,000.
So at least if you're going to go spend $10,000, $20,000, $25,000 for a microscope without being able to do the LMD, if you can justify this as part of the LMD, then you can actually do 2 microscopes in one. You still have the fluorescent capabilities with this microscope. Even with the older slides, you may not, if you do the past slides, you cannot do the laser microdissection, but at least you can do some identification with that. What are the downsides to this? One, it adds extra step to analysis. Right now you're doing your Christmas tree stain and you're looking at the microscope. If you find spermatozoa, you can go ahead and cut them and be done with it. What if you don't? What if you do have a situation where you see you have maybe 1 or 2 or 3 sperm, you're not sure you really have anything, or you're certain you'd rather check a little bit more? It does add an extra step, but it's something that can give you more confident IDs. It does require a little bit higher quality microscope. As Andy was saying, you really want to look at a little bit better. The quality of the microscope you're looking at is going to be in the $20,000 to $25,000. You can actually do bright field with a lesser quality microscope. But it does require a higher quality microscope with fluorescent capabilities. If you go ahead and get your laser microdissection scope or laser capture scope with the fluorescent capabilities, you have the built-in capability to do this, plus any other fluorescent applications that are out there. Here's one of the products I've looked at, Sperm paint. Here has antibodies to the equatorial segment. SP10 is acrosomal protein, and Caber A is the tail. That's calcium binding tyrosine receptor. That's where the Y comes from, the tyrosine. If y'all remember your single codes for your amino acids. Procedures: add the antibodies to the sperm overnight at 4 degrees centigrade, wash with water, and examine it. Look at the top slide up there. Yeah, this one might be one you want to lower the front lights on so people can see. Look at the top slide and look at and go in there and you see, yeah, the sperm are there. They're not too hard to find. That's the easy one. But look at the bottom. Can the people in the back, all those little bright spots. Let's see if I can get this to work right. All those are sperm, and all those little bright spots like that are sperm. Can you imagine how easy it would be to search that whole slide and look for those bright spots, as opposed to searching the top slide? That's the same slide, the top and the bottom. One's taken in bright field, the other's taken in that. When I looked at most of the time when I search them, I search it about with the 4DX objective. With this fluorescent sperm ID, I can drop down to 200 or the 20X objective and search the slide just as easily with the same confidence. Now, one thing about magnification, when you drop down from a 20 or from a 40 to a 20X ID or objective, you don't double your search area, you quadruple it. So now you can search 4 times the area with a 20X objective than you could with a 40X objective. So this is going to cut down, this has the capability of cutting down your searches, and to my opinion, it gives you more confidence in your identifications or in your negatives.
I think some of the people, yesterday, someone asked, in our lab it's policy to search the whole spot before we can say, negative for sperm. And so something like this might be useful, like even if you can't get a laser microscope, maybe you can convince your lab to get the fluorescent microscope and you could do something like this. But that might cut down on your times and help you to search quicker to see if you can find some sperm.
So to summarize the advantages of fluorescent sperm identification, simple procedure, and what I'm going to talk about, this is also a method of sequential processing of these samples. In other words, if you start looking at it with the Christmas tree stain or the nuclear fast red, if you don't go through the full stain, you find nothing. Or if you find something, of course, then you can cut them out and do the analysis. But if you find nothing, you can then process it with this, sequential processing. At this point, we really haven't tried a lot of DNA analysis with the fluorescent sperm antibodies. It's just because these products are hard to get right now. This is, as I said, there's no commercial available product on the market right now, so you have to go to the researchers or beta kits to get this material. So I really have to try the DNA analysis on it. But these are proteins. They really should not have any effect on the DNA typing of these samples. Now, we have done some work with other fluorescents where we've gotten successful DNA typing. Samples can be examined at lower magnification, which means it increases your rate of searching. It improves your confidence in the fact that there are no spermatozoa there. You can also see sperm under cells. That raises the issue of how you're going to cut those out. Because if you had a lawn of cells that are covering the spermatozoa, you can't see them under the normal microscope. In this case, you can see spermatozoa that are fluorescently labeled that are under other cells, under the epithelial cells. So this is actually an improved capability. Fast examination, confidence in negative results can be done on older slides. Again, you can't do the laser microdissection or laser capture on the older slides, but you can examine them. And the slides I just showed you there, we have done this on some casework samples because we've gone back and I've looked at some old slides from what analysts have had from cases that they worked a while ago. But the one that I showed you was actually like a K-mix or our known mix that we use in our preferential lysis. I just went back and picked up an old slide and put it in there and stained it and got those results. That was a slide that's probably at least a year old when I looked at it. This also works on the pen slides. One of the problems with some of the fluorescents in the pen slides is there are fluorochromes that can't be used on the pen slides. However, apparently they can be used, and we've done some work with them, and they do work on the pens, on the director slides. But the pen slides do have some autofluorescence, but not with the green fluorescent dyes or the red fluorescent dyes.